Here we go. I don't know. Seems to be recording, so that's good. We'll see. I thought I got it all figured out over the weekend, and then it turns out you can't record your screen and project at the same time. So, but hopefully this will turn out. If it doesn't, well, I'll figure something else out. So you got one of these. Like I said, I print this out. Kind of has everything you need to know about the course, nothing that you don't. Okay, so on the left-hand side is just any contact information. I don't have a ton of office hours because I find no one really shows up for them anyways. So just let me know and I will just pick a time that works for both of us and then go from there, right? Like I think I said last week, as a rule, if I'm here on campus, then you can come see me anytime, right? I'll even come to campus for you within reason, okay? So we're gonna have assignments and 3 tests and the final exam, and that's all that's gonna be your grade. So we have 15% is gonna be assignments. It's gonna be split between handwritten and kind of hand-in assignments and Moodle assignments, just to make my life a little bit easier. So there's 3 tests. They're weighted increasingly more as we get through the term. Just kind of consider it an importance meter. Right? Test 1. We just got to get through it. Test 2, a little bit more important. Test 3, definitely important. And then we have the final, very, very important. Okay. Did I tell you my policy for missing tests last day? So long ago, I can't remember. Okay, so if you do miss a test, things come up, things happen. I know you can't always help it. Doesn't matter to me, right? I don't offer makeup tests. I just put the weight of that test on your final. Okay, makes for a heavier final, but it just is the easiest way to deal with it. So that's just what I do. So there will be no makeup tests, just that weight will be put on your final. Okay. I do prefer that you write the tests, and if for some reason it doesn't go well, then don't worry about it, right? If you do better on the final, I'm happy to I just put the weight of that test on your final as if you never wrote the test, okay? So at the end of the day, just focus on the final. I don't want you to get hung up on these tests throughout the term because there are a lot of things going on, right? And we all have bad test days. I understand that. So I don't want you to get kind of flustered if you have a bad test. They shouldn't be bad, but things happen, right? So that's my policy. Okay? And then I have kind of your class schedule. I like to break it up by weeks. What's nice is we're already in week 2 out of 14, so not bad, right? And here's a rough breakdown of what we're going to be covering every day. So the dates on here is pretty faint and on here too, but right, section 1.2 and 1.3 is what we're covering today. So if for some reason you have to miss class, I don't care. I care about you. I don't care if you come to class or not. Right, so as long as you're staying on top of the material, that's great. Hard to do if you're not coming to class, but that's just a fact. Okay. So today 1.2, 1.3. Next day 1.4, 1.6. There is a little bit of wiggle room within the weeks, but in general, we're going to cover chapter 1 this week, chapter 2 next week, chapter 3. That deal. Okay. What you'll see is I tried to put all the tests on the kind of the Tuesday. So because for each test, we have a review day the day before, and then we have the test, okay? So I want to have as much time for you in between, but the first test didn't work out that way. The first test is on the Thursday. Oh yeah, you guys got a little freebie. I didn't know what to do. So I have the same class Monday, Wednesdays, but we have these 2 Monday holidays. So I figured you guys, well, it'd be unfair and really hard on me to do kind of shifting off the classes. So I'm just canceling class the Tuesday after Thanksgiving and the Tuesday after Remembrance Day. Hopefully no one minds. That way you have the same amount of classes as the other guys. And it's my only class on Tuesdays, so works out for me too. Okay. But then, like I said, so test 2 and test 3, we have the review on the Thursday and then the test on the Tuesday, so that you have all weekend to go over that review. Okay. Any questions? Cool. All right. That's it for the term schedule. So let's see here. Before we start, so you had kind of fake homework, right? You were going to buy the textbook and you were going to buy the calculator, right? And I was like, oh, I haven't done it. Okay, just pretend that you did, okay? So if you're just opening up this calculator for the first time, we have to set it up so it's working like we need it to work, okay? Let me see if I can figure it out here. Okay. Hey, there's you guys. It's a little laggy, but whatever. Okay, so here we go. Here's your fancy calculator. Right? Okay. The instructions are in the textbook, but I figured I'll just walk you through it. Once you've set it up once, you never have to do it again, so it's good. And if you don't have your calculator here today, then I can just set it up for you later. Okay, no biggie. First thing we want to do is, by default, it only shows 2 decimal places. That's not very helpful. So we're going to change the number of decimal places that it shows. Okay, so to do that, you're going to hit second, and the little yellow button. Oh, it's so laggy. Anyways, I'll slow down. Hit the format button. Okay, so by default, it says 2. Oh, refocus issue. Okay. Fun. Oh. Oh, there we go. Okay. To set it to 9, which is what we want to do, okay, you're gonna, so it'll say 2 with no, so once you hit 9, I guess that's what I should do. I'll hit 9, and there's no equal sign here, right? To get the equal sign to set it, you have to hit enter, okay? So the enter button's at the top here, and now you've got this equal sign, right? And so now it's been set to having 9 decimal places. You can change it later, but why would you? The next thing we want to do is we want to change it from, well, not knowing BEDMAS to knowing BEDMAS. We're going to talk more about BEDMAS today, so stay tuned. Probably pretty familiar to most people, but I want everyone to be on the same page. Okay, so you're going to kind of scroll down through. The next one is degree mode. We're going to leave that alone. Scroll down again. There's the date setting. We're going to leave that alone. Don't know what that is. We're going to leave it alone. And then you have this AOS, but by default, I think it says CHN, right? So we want to change it to AOS. So to do that, you're going to hit second set. Okay. And then it'll just change. Okay, so I'm going to change it back to AOS. Okay. So once it says AOS, then now it knows bedmass, whereas before it just treated it like a chain and just went through whatever you entered, and it didn't care about bedmass. Right? Not really sure why that's the default, but whatever. Okay, we've changed it now. Okay, so we're in what I'm going to call a second menu, right? We had to hit second format. Right? So to get out of a second menu, you're going to have to hit second and then quit, or the CPT button, compute. Okay, so second, quit, takes you out of there. Okay? And now you're back to a normal screen. Neato burrito? Cool. So if there's anything that you missed there, then just let me know and we'll fix it later. Okay. Switcheroo here. Where was I working? Oh, I know. I know what I want to do. So I just want to mention at the beginning of the term now that you do have resources. So if for some reason you don't want to come see me for help, then there are other resources available. One of which is the Learning Center. I'm not sure where exactly in the library it is, but they do have a math tutor there, and it's free, and you go there and probably wait in line for a little bit and wait for someone to be available, and then there'll be more people working on business math. Don't worry, right? So that's really good. It's nice to have free tutoring available to you, right? Or if you're looking online, Khan Academy is really good. If you've heard of Khan Academy, he does these short little videos, but he does a really good job of explaining things. So let's just talk about, I'll change this. Okay. So some resources to keep in mind. The first one is the Learning Center. Which is just free tutoring. Don't worry, they get paid, but you don't have to pay. Right, so that's a pretty good deal. Okay. Or later, if you excel in this course, I'm sure you could work there. Think about that for a second. Oh, very interesting. Okay. The second one is Khan Academy. Khan Academy is really good. The trouble with Googling things, right, is often you don't know what you need to Google, right? You're struggling with this problem and you know you have to look something up, but part of the problem is not knowing what you have to look up, and so you're stuck, right? So if that's the case and you're trying to get through it by yourself, then just send me a message and say, hey, I'm working on this problem. What should I be Googling here, right? Because that shows me that you're trying to do it on your own, and you just need that little extra bump, right? And so I like that. Okay? Or I can just help you if you'd prefer, but like I said, I do acknowledge that sometimes the hardest part is knowing what to Google, right? Okay. So today we're going to talk about basic math things. Okay? The reason we're going through it and kind of being thorough about it is because we're all at varying levels of math exposure, right? And so I want everyone to be on the same page and just kind of know what I expect you to be able to handle. Okay? So if you're a math whiz, then that's great. You can just sit back and feel good about all the things you know, right? And if you're not feeling that confident, don't worry, you've got time. Okay, okay. So let's start with section 1.2 is called Order of Operations. It's the kind of the foundation of all the math that we do. There are rules involved, right? And how do we solve a math problem? Okay. So you've probably heard of BEDMAS, maybe. Brackets, exponents, division, multiplication, addition, subtraction. Okay. But BEDMAS, it really just tells us the order of our calculations or order of operations, right, of our calculations. Oh. I'm always, so yesterday, I forgot to bring my phone charger. And so I came up, I was like an hour in and came up with a low battery. But okay, we're no longer working in time, we're working in percentages, battery percentages. I was hoping that wouldn't happen today, but here we are. Yeah. Oh, it's my pencil, I think. Thank you. I know I came prepared with my charger today. So I was feeling pretty good, but yeah. Okay. So we're going to be dealing with, oops, I wanted to write them. Going down the page, BEDMAS. For brackets, exponents. Exponents are powers, right? Just so you know. Division, multiplication, addition, and subtraction. Okay. It's a little bit misleading because the D and the M are together and the A and the S are together. Okay. So they're actually on the same level. Okay. But what we do is if you have division and multiplication in the same expression or equation, then we do them in order from left to right. Same thing with addition and subtraction, right? How do you choose which one to do? Well, you work in order from left to right, okay? So these guys, they're kind of, should be beat up, but I can't do it. I'm trying to put the D and the M together and the A and the S together. They're not their own. Anyways, tricky. So for these guys, if there is both division or subtraction, or sorry, division, multiplication, or addition, subtraction, okay, we do them in the order they appear from left to right. Okay. Cool. Just a quick example. I'll try to reference the textbook. I'm not rewriting the wheel here, or rewriting the wheel, reinventing the wheel. If you have something kind of simple like this, 72 divided by 3 times 2 minus 6. Right. First stop brackets. We do have brackets, okay? So inside those brackets, we have to deal with whatever's inside. If there's brackets inside those brackets, we have to deal with what's inside those brackets. right? So we keep having to start over in BEDMAS, right, until we've reached the end, right? So here there's just 3 times 2 inside the bracket, so there's really only one thing that we need to do, okay? So this becomes 72 divided by 3 times 2, 6, minus 6. Okay. And now we're dealing with division and subtraction. Division comes first. So first we have to do 72 divided by 6, and then we can subtract 6. You can see the disaster that would happen if we did 6 minus 6 and then divided by 0. It's illegal math, right? Dividing by 0. Can't do it. Okay. But 72 divided by 6 is 12, and then we can minus 6. So we get an answer of 6. Okay. Cool. Nice. All right. We'll start a slow burn here. Example 7. How about if we have 72 divided by bracket 3 times 2 to the 2 minus 6. It's the same, just the slight variation, right? Now we have 2 squared. So inside those brackets, there are no more brackets. So then we move on to exponents. Okay, we need to deal with those exponents first, or that exponent first. And then we can multiply by 3, right? So we have another step in here. So we have 72 divided by, keeping the 3 times 2 squared is 4 minus 6. Now we pick up where we were earlier, right, in the example 6. 72 divided by 3 times 4 is 12 minus 6. Oops. 72 divided by 12 is 6. Oops. I meant to do it. 6 minus 6 is 0. Okay. Any questions so far? Yeah. Wouldn't you do 3 times 3 to 6 and no, because you're doing because there's multiplication here, right? But then you have this exponent, so the 2 is only. Yeah. But yeah, that's a good question. Any other questions? Cool. Okay. So let's get we're getting comfortable here. So let's start looking at example 8, okay, where we have $500, big bracket times little bracket, 1 plus 0.06 divided by 2 to the power of 10 minus 1 over 0.06 divided by 2, end of the square bracket. I'm not scared. We can do it. So here we're dealing with a fraction, right? So a fraction, and I'll just throw this in here. We'll talk about it more later, but because we're dealing with a fraction, we should probably know the fraction terminology. So the numerator is on the top, the denominator is on the bottom. Okay, I'll even change colors here. Pink, a little festive. So a fraction is a numerator, oops, over a denominator. Okay. Just because we need to be able to talk about fractions. Right. So for the longest time, I had a hard time remembering which one was which. Numerator, denominator, I could never keep them straight. until I figured, okay, the numerator is numero uno, so it's on top. And then the denominator, who cares? So, so that's how I remember it. Whatever you have to do, right? Because I will be calling them the numerator, the denominator, right? So you have to kind of keep those straight. Okay. We ready to tackle this behemoth? On the plus side, the math in this course isn't going to get worse than this, but a lot of this, okay, this type of equation, okay? So, but once we deal with enough of them, you'll figure out the kind of the procedure, and then you'll be all good. Okay. So it's $500. Of course, in this course, we're going to deal with a lot of monies. I don't actually care about units. Of course, in the real world, we care about units. They matter. But for what we're learning here, I'm not going to be very picky about units. Okay, so I'm going to drop the dollar sign, although they are fun to write. So if you want to stick with it, go for it. Okay. So just looking at this, right, we've got brackets, but then inside the brackets, we have more brackets, right? So we're going to deal with what's inside those brackets first, leaving everything else untouched, right? So we're just going to rewrite 500 times. And then, what's the first thing we have to do inside these brackets? Good. So we're going to deal with the 1 plus 0.03. Everything else just stays the same. I'm tempted to just reduce the denominator right away. You don't have to. I will, just to save a little bit of writing. Okay. So in the bottom, right, we have another 0.06 divided by 2. I'm just going to deal with it right away. What's nice is we actually solve the numerator and the denominator separately. So that's why we can do that. Okay. But if you want to leave it and just deal with one thing at a time, that's good too. Okay. All right. Okay. So it's going to feel slow going, but eventually we'll get there. Okay. So now we're going to do the 1 plus 0.03, and then everything else stays the same, right? Still working in those brackets. So we have 500 times 1.03 to the power of 10 minus 1 over 0.03. Okay. So now we have just essentially one bracket. I kept the little brackets, but they're only bracketing one number, so you can ignore them, right? They don't do anything. So we have one set of brackets. Next up, exponents. We do have an exponent. Okay, so we're going to do 500 times, and I'll show you how to do 1.03 to the power of 10 in just 1 second. But I'll tell you it's 1.34 minus 1 over 0.03. Okay. I've rounded before. Okay. Let's see here. Back to my. Hey guys. I always joke that I'm making a YouTube video. Hey guys, been getting a lot of questions about whatever. How to do 1.03 to the power of 10. So here we go. You're gonna put in your 1.03, okay? And then you can do to the power of 2 if you hit the x squared. That's an easy button. right? But if you want anything other than to the power of 2, you're going to hit the y to the x button. Okay. Nothing changes on here, right? But if you know you've pressed it, then you're good, okay? And then we hit 10, because we want 1.03 to the power of 10, right? And then we hit enter or equals. Okay. So it's 1.34391637. Yeah.
This one is showing the rounded figure. Is that same?
I'll change it for you. All right. It is done forever. Let me just change one thing. Okay. So here's the, yeah. 1.03 to the power of 10. Not that we'll do. I mean, you could do 1.03 times 1.03 times 1.03 times 1.03 times blah, 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 1.03 if you want to. Yeah. Yeah. Excellent. Here's the deal, guys. Okay. I want you to keep all your decimal places on your calculator. Okay. I don't need to see all the decimal places in your work. Okay. So I would show 3 or 2 or 3 or 4. Okay. If it's important, I'll tell you on a test, for example. I'll try to tell you, if it's not obvious, show 3 decimal places for all your work or something like that. Okay. Minimum 2 decimal places, because a lot of the time we're dealing with money, right? So it wouldn't make sense to show less than 2 decimal places, right? But if you want to play it safe, then go 3 or whatever you feel like, but minimum 2 decimal places. Okay. So, but we're going to keep all our decimal places in our calculator, okay, in our work, and I'll show you how to do that. Okay. Any other questions? Cool. I'll make a note of that in the notes once we're done here. Okay, so maybe I should put some notes in right away. Here, I'll start with this one because we did kind of make a little exception, right? You can reduce it here at the beginning, or you can leave it to the end, okay? So we can reduce 0.06 divided by 2 here, or leave it until later. Okay, it's up to you. Okay. And let's do another one. Okay. Just some things that we've touched on, but we should probably make a note of, right? We solve the numerator and the denominator separately, independently, right? Which means that we can do them kind of side by side parallel, right? So, or we can, we just do, we solve the numerator and denominator separately. And I never remember how to spell separately, so I just try to fake it with like this E/A kind of fluid letter. E? Nice. I did. I'll never remember though. It's one of those things. Okay, cool. So, let's get back to this little pickle we've made here, right? But we've got it handled pretty well so far. So we've still got the 500. And only thing left in the numerator is 1.34 minus 1.34. But on your calculator, right, you would actually take all the 1.343, whatever, minus 1, right? So I'll show you an example. Okay. 1.34 over 0.03. Okay. So if you kept the 0.06 divided by 2 until now, this would be the time where you reduce it, right? So if you kept 0.06 divided by 2, this is when we reduce it. Just so we're clear. Okay. All right. Home stretch, 500 times 0.34 divided by 0.03 is 11.33. Okay. Putting you at 5,000. I'll throw the dollar sign in there. We know it's dollars, so why not? $5,731.94. What? I get 5,666.67 pennies.
Because you didn't keep all the numbers.
So here, the 5731.94, that's keeping all my decimal places in my calculator. Okay, let's do a green one. Keeping all decimals in my calculator. Okay. Without with rounding, I should say, you would get $5,666.67 if you worked with rounded numbers. On your calculator. Yeah.
On a test, are you going to want us to keep the original?
Definitely. Yeah. So this is important, right? If I was your client and you were rounding all my math, I'd be pretty peeved, right? I would only end up with $5,666 instead of $5,731. It's kind of a big deal, right? So even though it doesn't look like a big deal, right, we have to use all our decimal places in our calculations. Okay, so we must use all the decimal places. The decimal places in our calculations. Okay. Otherwise, we'll get the wrong number, right? So I'll just put a period there because that was nasty period. Okay. So we have to use all our decimal places in our calculations, right? That doesn't mean entering that long number in every single time. Right, there's going to be ways where we can store numbers and pull them back out, and little tips and tricks that I'll show you as we go. Okay. But let's also make a note here. We need to show at least 2 decimal places in our work. Okay. So those are just rules. Okay. Okay, so how would we solve this on our calculator?
Sorry, I got a conference call from work. I got
Don't
a
worry.
client, so
Have fun.
it's not fun.
Hopefully my recording works, because I know he's dying to watch it later. Okay, so starting from scratch here, I don't have my, well, I have, hopefully you have your little equation that we need to solve. Okay, so same thing, we're gonna work through our order of operations. So I'm gonna start with the 0.06 divided by 2. Okay. We had 1 plus 0.03, 0.03 plus 1 doesn't make a difference, right? So I'm just gonna go plus 1. Okay. So that's inside the small brackets, right? 1.03, so far so good. We're gonna do that to the power of 10, so y to the x, 10. Good, so now we have that number again. Right? And then we had to do minus 1, right? Minus 1 to finish off the numerator. Right, so minus 1. Here, it's nice to just do 0.06 divided by 2 in your head, or remember what it was from earlier, right? Because what we would do is we would have 0.3439 whatever divided by 0.03. So now we can just divide it by 0.03 equals 11.463879 blah, blah, blah. It's not quite what I had. Must have been using rounded values. It's okay. And then times that by 500. So times 500, you're done. Okay. So you don't have to enter any of these long numbers in. And if you want to know more shortcuts before we get to them, then just ask. But I will introduce all these shortcuts for when we need them. Okay. Cool. Any questions? So that was a big calculation, but like I said, all of our big calculations are going to be set up in very similar ways, right? So once you know how to deal with one, then you know how to deal with all of them. Okay. Cool. So we're going to talk about variables quickly. Okay. So a variable, you've probably heard it before. Variables to me were kind of like this thing that I know it's a word and I know, but I just couldn't get the connection. But it's really just, I knew how to use them and work with them, but it just took me a while to wrap my head around it. But it's just a placeholder, right, for a value. Okay. So a variable is a placeholder for a number, usually denoted by a letter. For example, we have something like 7a. 7a is just all the different answers that have 7 times whatever number you can think of is in the answer. Right. So if you've worked with variables before, right, then you've probably had to collect like terms. That's going to be really important for us, right? Just collecting like terms, simplifying expressions. Okay. So to simplify an expression with variables, we need to collect like terms. So for example, A's go with A's. A squareds go with A squareds, right? They don't go with A's, they go with A squareds. B's go with B's. X's go with X's, etc. Right. So if we need to solve an equation, then usually we're solving for the variable, right? And which means we have to collect like terms to get there, right? So if we need to solve something like A equals 60 plus 4 divide, oh, what the? Not sure what happened there. Divided by 4 minus 3a, right? We need to collect like terms to solve for a. That means that we have to group all our a's together, and then we can just do math on the coefficients, right? The values in front of the a, right? This a has a coefficient of -3. This a has a coefficient of just 1, right? So we need to collect like terms, and we could bring this a over to the right hand side. What's going to be cleaner, right, is just moving this 3a, -3a over to the left-hand side, and then we'll be one step closer, right? So let's start with our equation here again. A is 60 plus 4 divided by 4 minus 3a. Okay. Here's what I'm going to do. I'm going to show you every little step that I could possibly do, and then I'm going to do it again with what I expect to see from you, okay, because it's much shorter what I'm expecting to see, right? But I also want to show you exactly what's happening in case it's been a while, okay? So to bring something over to the other side, right, we have to do what I would call the opposite, right? So if it's being subtracted on one side, we have to add it to both sides, right? If it's being multiplied on both sides, we have to divide it on both sides, right? So division, multiplications, those are opposites. Subtraction, addition, those are opposites, as I call them. Probably not a technical term. Okay, so to move this -3a over, right, we have to add 3a to both sides, right? So our next step would look something like a plus 3a is 60 plus 4 divided by 4, still minus 3a, but also plus 3a. And that makes it go away and move it to the other side. Okay. So now that we have -3a plus 3a, we could cross them out or something. I'm just going to rewrite it as 60 plus 4 divided by 4, essentially plus 0, if you want to highlight that. All right. A plus 3a, because we have these two like terms sitting together, right, then we can just do math on the coefficients. So we have 1 plus 3 times a. Right. I'm not going to show the step, but technically I've pulled out the common term a, dealt with the inside, but that's too much. I think we're all kind of on the same page, putting us at 4a. Right? So then we'll simplify. So we'll leave 4a as it is for a bit. And then we have 64 in brackets divided by 4. 4a stays the same. And 64 divided by 4 makes 16. Okay. And then a is being multiplied by 4 on the left-hand side. So to get a just on its own, right, to finally solve for it, right, because 4a is 16, right, but we just want to know what a is. And so now we have to divide both sides by 4, right? So we get divided by 4, divided by 4. 4 over 4 cancels out and makes 1. Right? So we have a is 4. Okay. That's a lot of work to show, right? So I'll just show you what I would expect to see and nothing less. Okay. So to solve this, I expect to see the following amount of work. Starting with a is 60 plus 4 divided by 4 minus 3a. Okay. I do want to see the plus 3a on that side. Later on in the course, you can move to just writing 4a, but what's the harm? Yeah, I would just do it. Okay, so if you have something that kind of covers showing that much, then you're good. Okay. And I want you to, I'm not going to assign any homework from today later, but if this is feeling a little bit rusty, then you should go through and work through a ton of those practice problems just to make sure that you're getting into the groove. Okay. So what's really important, and what I probably the most common illegal math, well, there's two things, and we'll talk about them today, but the first one, illegal math that I see is just not doing to one side what you do to the other side, right? So we have this equal sign, an equal sign, equality, right? So we have to do to one side what we do to the other, right? So I'll just make a note here. Whatever you do to one side, you must do to the other. Otherwise, the equality is lost. Oops. No, I don't want to. Okay. Okay. So it's a rule, and I know it's easy to forget rules sometimes, but it's a rule. Okay. How about, oh, what's happening? Oh, is it my pen?
I think so.
Oh, crud. All right.
No dry
It they tell me it only needs a minute or less than a minute. Well, maybe? I don't know. I'll try it now. Feel bad for those guys who left. 3x plus 2y. Weird. Okay. Equals 10x minus y. Solve it for x. Okay. So I'll give you just a minute while I charge it some more because I don't think it got enough. Okay. And then we'll go through it. Put that. Oh yeah. I am coming for dinner tonight. Sure. He'll think this is really funny. It's my brother-in-law, and this happened yesterday morning too, but it was my husband, and luckily he kept it pretty PG, so, but things got a little, he thought it was really funny though. I thought I put it on Do Not Disturb. I guess I don't know what Do Not Disturb means. Okay. Okay, so anything can happen. Stay tuned. All right. All right, let's do this. I think it's charged. So I guess that's the risk, working on your own devices. All right, so we've got, I'll just rewrite it here. 3x plus 2y is 10x minus y. We want to solve for x, right? And so we know we have to collect like terms. We have to collect the x's together, collect the y's together, right? Here, it's whatever you prefer, right? You can move, I would move, you want to get x's on one side and y's on the other side, right? So that's step one. And then whatever you prefer, if you want x's on the left or x's on the right, doesn't matter, right? You'll get to the same thing in the end. I like to kind of survey the scene and avoid negatives. Because for some, I don't like working with negatives. So that's just something that I like. So I do whatever I need to do to have as few negatives as possible, right? And so I see, okay, well, I can add y to both sides, right? So that moves that over here. And then to move the x over, then I'm subtracting 3, but subtracting 3 from 10, so cha-ching. All right, so that's what I'm going to do. But either way you move is fine. Okay, so to be quite honest, I'd probably do the move like this in one move, but for now I'm going to be proper and show it in 2 steps. Okay, so 3x plus 2y plus y is 10x. 2y plus y is 10x minus 3x. Notice that I'm not actually showing what I'm doing to each side, right? Because if I'm only doing one thing at a time, then it's pretty obvious. Right? So now that I have my y's together and my x's together, then I can just collect my like terms and solve for the coefficients. Okay, we're solving for x, right? Which means I need to shake the x out, right? So x is being multiplied by 7, so I need to divide both sides by 7. So we have 3y over 7 is x. Okay. Usually what I would do here is I would probably not write this. I would have probably just shifted them around, and I would have written x on this side. X is 3y over 7, just because it's like a hang up of mine. I just put, so at the end I just switcheroo, and I like to have x equals whatever, but nothing's changed, right? So, and we're done. You don't have to reduce it or anything. Even if you could reduce it or simplify 3 over 7, right, then don't, right? That's not what we're here for. Solving for x, that's what I asked you to do, and you did it. Okay, any questions? All right. Example 12. Combine like terms. So just combine them. We're not solving or anything. Okay. We have 1.0164x plus 1.049x minus x plus 3x squared minus x squared plus 5x squared. Okay. Not that bad. Scanning the line up here, we've got x's and x squareds, but then that's it, right? So we can just group our x's together, and I'm just going to do it by putting brackets here and our x squareds together, putting brackets there. And now I can just treat or work with the coefficients. Okay. So technically what we're doing, and I'll show you here, is we're pulling out the common x in this first bracket. So x times 1.0164 plus 1.049 minus 1. Okay. Okay. Don't forget that minus 1, because it's important, right? We still have minus x, so we have to keep it in there. So plus, pulling out the common x squared, 3 minus 1 plus 5. Whoops, ugly 5. So now we have x times 1.0654 plus x squared times 7, which is, now it doesn't matter. X times 1.0654 is the same as 1.0654 times x. I just prefer to, at the end, move my variable to the end. Right. I write 7a instead of a7. Right. So I'll just rewrite this as 1.0654 x plus 7x squared. Okay. It's a good idea to get in the habit of writing polynomials like this in order of descending powers, right? So it is a good idea to get in the habit of writing expressions. This is an expression in general, in order of decreasing powers. So we would write 7x squared plus 1.0654x. This is the exact same thing, right? If you plug in a value of x, you would get the same answer. It's not that. It's just if you're ever dealing with polynomials, right, we would call this a second degree polynomial, and you could just see it right off the bat, right? So it's just kind of a good habit to get into. Okay, I'm gonna skip that example because it's long and whatever. Any questions about that stuff? No? Then we will move on to section 1.3, which is rational numbers. Rational numbers are really just fractions. I'll never call them rational numbers. It doesn't resonate. So also known as fractions. So we've already seen some fractions, right? Let's just make a quick note here. Again, because it is terminology that I need you to be comfortable with. A fraction is just a numerator over a denominator. Okay. So we need to, like I said, we've already seen a fraction. We're going to be dealing with a lot of fractions in this course, right? And so we need to know the rules for working with them. Okay. And I think I stray from the textbook a little bit because I'm going to start talking about multiplying fractions, and then, because it's actually the easiest, and then dividing fractions, and then adding and subtracting fractions. So it's a little bit trickier. Let's talk about multiplying fractions. Okay. To multiply fractions, simply multiply across, right? So the numerators are multiplied together and the denominators are multiplied together, okay? So simply multiply across. So I'll do these examples with variables, right? Because those variables can take on any value, right? It makes a little bit more sense. So if you have something like A over B times C over D, right? What I mean by multiplying across is just that this becomes A times C, right, over B times D. Do a quick tiny example, example 16. 38 over 55 times 15 over 2 is going to be 38 times 15 over 55 times 2. In the future, I'll probably move towards just putting one of these guys in brackets instead of using that x, the multiplier, just because it's cleaner. But for now, I'm being a little inconsistent in my multipliers. A and C are being multiplied. These two are being multiplied. These two are being multiplied. But hopefully you recognize that they're all doing the same thing. Okay? So this becomes 570 over 110. I would just leave it at that, right? We can definitely simplify this, but who cares, right? The idea is, do you know how to multiply fractions? Yes, you do. Great. How about dividing fractions? Okay. So you've got a fraction over a fraction. Right? So what we're going to do is we're going to flip and multiply. Right? So whoop, whoop. Okay. I'll show you with variables, but I think it's easier to just think, oh, okay, done, right? So to divide fractions, or to divide two fractions, we need to flip the denominator and multiply it by the numerator. So in variables, if we have a over b all over c over d, notice I use a longer division. Otherwise, it could get confusing. This is going to be the same as a over b times, good. And now you know how to multiply fractions, so just becomes AD over BC. Okay. Cool. Example 17. He made spanakopita.
Yeah.
Oh, yeah. I don't know what to do. I'm just too popular, I guess. Let's do 18 over 5 divided by 27 over 15. You can go from here, right? 18 over 5 divided by 27 over 15. I like to visualize one over the other. So I'm going to rewrite it, but you don't have to. Okay. So I'm just going to rewrite it as, oops, that's not it. 18 over 5 divided by 27 over 15. Keeping the numerator still and taking the denominator and flipping it and multiplying, I get 18 over 5 times 15 over 27, making 270 over 135, which turns out to be 2.
Is there a reason why you flip the second fraction?
That's just what, my goodness. Is there, I'm just flipping the denominator, but if you want to flip you can. There's the 1 over x, which will do 1 over whatever you have. No, you'd have to put it in brackets. So you'd have to do bracket 18 divided by 5 and bracket divided by bracket 27 divided by 15 bracket. It might do it in the background, so it doesn't show it. Yeah. No. So
So if I flip, I did 5 over 18 times 27 over 50. That would be 135 over 270. So all I did was flip the 18 over 5 instead of the 27 over 15. I flipped the first fraction,
Yeah.
and I got the opposite.
okay. 5. I guess I just always, I just flipped the denominator, so maybe just do that. Yeah, because it doesn't work out to the same thing. Yeah, I would have thought that it would, but it doesn't. Cool. All right. We ready to add and subtract some fractions? Cool. So adding and subtracting fractions adding. Sneak that in there. So adding or subtracting two or more fractions just means that we have to get the same denominator, right? We have to have a common denominator before we can do anything. There's lots of ways that we can find common denominators, but the safest one is just to cross multiply. Okay, so I'm going to show you that way, and I will probably only ever use that way. Okay? Even though there are cleaner ways to do it, I like to use the safe way to do it. Okay, so adding and subtracting two or more fractions can only be done if they have the same denominator. Okay. So the safest way to get the same denominator is to cross multiply. So we basically just use the trick of multiplying by 1, right? And so, for example, if we want to find, example 15, if you're counting, if you want to find 15 over 22 plus 1 over 2, right? We can't add those together as they are, right? Because 1's over 22 and 1's over 2, right? And so what we do is I take whatever is in the denominator of the first one and I turn that into 1, right? 22 over 22 is 1, right? So I multiply this side by 22 over 22, and then I multiply this side by 2 over 2. 2 over 2 is still 1, right? And we know multiplying by 1 doesn't actually change anything, right? And so what we end up with is, it looks kind of nasty, but it's okay. 15 over 22 times 2 over 2. Right? Just kind of taking what's here. I'll do a little what's over here and just kind of multiply by 1 and take this guy over here. So 15 over 22 times 2 over 2 plus 1 over 2 times 22 over 2. 22, sorry. Okay. So here, what we're doing is we're just multiplying by 1. Right? So that's why we can do it. Nothing's actually changed. We're just multiplying these by 1. But now we can deal with this little chunk on its own, right? And this little chunk on its own. They're just being multiplied together. We know how to deal with that, right? And so we get 15 times 2 is 30. over 22 times 2 is 44. Plus 1 times 22 is 22. Over 2 times 22 is, again, 44. Phew, because that was the whole goal of the operation. Right? So now that we have both of these terms over 44, right, they're on the same level. So now we can add them up. And what we do is we actually only add the top, and it's going to be over 44. Right? And so we get 52 over 44. Okay. So notice that when we're finally adding these two, right, we only really add or subtract the numerators and leave the common denominator, right, as it is. So notice when we finally add or subtract, the two fractions, we only add or subtract the terms in the numerator. Hey, too chatty back there. The terms in the numerator, okay, and leave the common denominator. Okay. So subtracting, of course, works in the exact same way as adding. Nothing changes except you have to subtract, obviously. Okay. If it's jumping out at you that it's what it is simplified, then yeah, do it. But I'm not looking for simplified answers. If I am, I'll tell you to give me the simplified answer. I do prefer often if you just leave it as a fraction as opposed to a decimal, because usually the decimals you have to round them, making them less precise than the actual fraction. Okay. Cool. Any questions? That's all I've got. Hope you're not upset to be ending early. See you guys on Thursday.
Fine if I do it like this way.